Hey guys, here are some notes on how to write equations. So we're going to go over our three types of equations that were mentioned in the slides: molecular, complete ionic, and net ionic. And I'm going to give you some steps on how to write those equations. So remember that molecular equations are just like any of our double replacement reactions that we've predicted before, right? So I'm going to write same as double replacement ish, right? So we're going to add a few steps here. And so when we write our molecular equations, right, step one, I think it's beneficial to write the oxidation numbers of each species at the top, right? Once I have those oxidation numbers, right, I'm going to switch partners. Cations go with the other anion, and the other cation goes with the first anion. Double rainbow, right? It's outers, inners, just like we did before. Okay? And then after you switch, right, those partners, just remember that their oxidation numbers come to the new side, but not the subscripts. So then step three, we're going to recross charges, reduce if you need to, right? And then step four, balance. So those are all the things that we've done before. There is a new step, right? A new step in town. And that new step is then to step 5, and I'll put them in a new color, right? Is to check your solubility table so that you can write the state of matter. Okay, whether it is aqueous or a solid precipitate. Okay, or in some cases, water. H2O is not aqueous, it's water, and it's a liquid. So let's do an example, right? So let's say I have some magnesium chloride that's going to react with some lithium carbonate. Okay, these are both aqueous in solution. So step one, right, I'm going to write the oxidation numbers at the top of each thing. So magnesium is a +2, chloride is a -1, lithium is a +1, and carbonate is a -2. That means, right, I'm going to switch partners. That +2 magnesium is going to come get the -2 carbonate. So on my product side, Mg is going to come with CO3. They're a +2 and a -2. You can write them here or not write them there, but we're just going to leave that alone, okay? And that's going to also form that lithium is going to come get that chloride, right? And so we're going to form lithium chloride. These subscripts don't come with them. Lithium's a +1, chloride's a -1, so there are no subscripts. And so I don't have to really cross any charges here, but remember that you could have to. And then balancing that equation, I actually need to make 2 lithium chlorides to balance that they had subscripts in the reactant side, but not on the product side. Now we're going to check our solubility table. Magnesium chloride is a soluble aqueous solution. Lithium carbonate is a aqueous solution. Now find Mg and CO3. And when you do that, right, you're going to find that that is a solid, insoluble solid that has formed. And then lithium chloride is aqueous. And that is my molecular equation. To write a complete ionic equation, then, we're going to add some steps to this process. So then, right, step 1, dissociate all AQs. Okay, if it says AQ, it's going to split into its separate ions. Step 2, right, when we dissociate those, remember to keep balanced. So for a complete, if I took this MgCl2 plus Li2CO3 producing magnesium carbonate and lithium chloride, I would dissociate those, right, into magnesium ions. It's an ionic equation. You have to show the ions. And then it says MgCl2. That means that when Mg and Cl dissociate, it actually will dissociate into 2 chloride ions. So too, the lithium chloride, the lithium carbonate, when the lithium carbonate dissociates, those 2 lithiums will both dissociate from the 1 carbonate ion. Then you're going to form magnesium carbonate, but that does not dissociate because it remains solid. Solid things stick and precipitate out of solution. They sink to the bottom. Oh, that should be a plus sign, sorry. And then the lithium chloride is aqueous, but that 2 in front distributes to both the lithium and to the chloride ion. So these are all aqueous in solution. This is our solid precipitate, and this is also aqueous in solution. So then all you have to do after you have a complete ionic for a net ionic is just to delete the spectator ions. And you write what's left over. So deleting the spectator ions, again, back up here at the front, I see that I have 2 Cls that are identical on both sides. I have 2 lithium ions that are identical on both sides. So these are my spectators that I delete. And my net ionic equation is just Mg with a +2 charge. It's still an ionic equation. You must show the ions. Plus a carbonate ion makes magnesium carbonate. Again, these are aqueous in solution, and this is solid. And so that is our net ionic equation. However, there's also a quick and dirty way to do a net ionic that I want to also mention here, right? So a quick way to write just a net ionic equation when given a molecular equation, right? If given a molecular, all you have to do is find the precipitate and write the ions that made it. And that's it, right? If you're not given the full molecular, you will still have to predict those products and find out which ones are soluble. But once you do that part, then this is also your only step left, right? So, for example, let's say I want the net ionic equation for when I don't even know. I'm trying to think of one. Lead 2 nitrate reacts with, let's go calcium chloride. This will be a really simple one, right? So if I'm not given the molecular, let's just go ahead and do that one. These are both aqueous in solution, otherwise they wouldn't react. I'm going to write the charges just like I would for any molecular, and then switch the partners. Lead is going to come take the Cl, right? And I'm going to recross that charge down. Calcium is going to come take the nitrate, and I'm going to cross that charge down. Checking my solubility table, lead 2 chloride is a solid precipitate, but calcium nitrate remains aqueous in solution. So if I don't need the complete ionic, I'm going to copy down what the solid precipitate was that I formed, and then just write the ions that make it up. The lead 2 ion reacted with 2 chloride ions to produce lead 2 chloride. And that's all I have to do, is just backtrack what those ions are. And there's my net ionic. I hope that was helpful. Have a fun time doing your homework.